pharma, brings over 15 years of experience in statistical programming, CDISC and clinical data standards, and has worked across both sponsor organizations and clinical CROs. Thomas has also over 15 years of experience in statistical programming, and he mainly works on SDTM, ADaMs, TFLs, and enjoys creating reusable programs and macros to simplify processes, improve consistency, and make everyday work easier. He also contributes to system design and setup tasks, including the implementation and QC of EDC and SEE systems. And while his primary experience is with SAS, he's also familiar with R or Python, various shell scripting languages, and even VBA. And by saying this, I will hand over to good luck with the presentation.
Thank you for the introduction. And it's really nice to see you all here who are interested in our presentation. So thank you for the opportunity. So even today there are some companies who treat Define-XML as an afterthought, generating the Define-XML at the very end of the programming. So when the timelines are tight, when the pressure is high, so building a Define-XML at the end of the study is like assembling an IKEA furniture at the midnight, although it's technically possible, but emotionally draining, with back and forth fixes and many reworks, and slowly realizing that the quality is quietly slipping away. So I'll be honest, we were one of them until last year. So we stopped and we asked ourselves a question: what if we flip this whole thing around? What if we made the Define-XML as a backbone, not like a bottleneck? What if we treat Define-XML to improve our process of a dataset generation and to be proactive and create a Define-XML submission ready right from the beginning? So that's where our journey started. So we envisioned a integrated, standardized, collaborative workflow, and that helps improving the efficiency and traceability. So turning the vision into reality means to have a framework which is scalable, flexible, and also agile, and having the traceability built in. And most importantly, this is not like a build it once and walk away solution. It needs to be a living, evolving project where we continue to build, refine, and improve as we fly, hopefully not crashing. So the result is an in-house metadata-driven framework, which is automated, which helps us to, which uses the Define-XML as a backbone tool, and which bridges the prescriptive metadata and the descriptive metadata. So we use Define-XML in our process, and this transformation is driven by the shift from the reactive to a proactive metadata management, from a last-minute panic creation of the Define-XML to a proactive continuous tool. But it's not just about the creation of the Define-XML, it's much more than that. So this is our story. So our framework is built on two important pillars: driver program and the modular approach. So the driver program sets up the environment, creates all the global variables, and orchestrates the workflow, and it prevents the multi-user conflicts. It's like having an adult in the room who prevents us stepping on each other's code. And the second pillar is a modular design, which brings the flexibility to our framework. The modules are self-contained and purpose-driven, and then all the modules need to follow certain coding guidelines, and they should support the plug-and-play expansion. It's just like building the Legos. So these two pillars help our framework to be scalable, to be consistent, and future-proof. So we built a centralized metadata-driven framework, integrating the entry specs and data from the multiple sources, and to automate processing and generate one single reliable source of truth. That's the P21 ready Excel output. So I'll share more about these components in the next slide. So there are three framework components. The first one is the entry file. As the name indicates, it's the starting point of entering the study metadata. So it's a pre-populated P21 style Excel template, which we are all familiar with. And it has been optimized for the usability, like reordering some of the columns, and we have also added some special purpose columns, and we also added a drop column for the trial specific exclusions. So the next component is a processing tool, alias P21 Spec Creator. So it processes the entry file and data from multiple sources, and it restructures and creates an upload file. And it also flags the easily correctable errors, and it saves the reusable it saves the data set for the reusability for later purposes. So it's like that one programmer who never complains of doing the boring job, but efficiently flags all the issues before everyone does. So, and the last component is the upload file. As name indicates, it's a ready to upload file to generate the Define-XML using the P21 community or P21 enterprise. So it's a write protected Excel file having all the metadata, but it's not just for the Define-XML creation, but it's also used for the dataset generation and then ACF creation and draw data to SDTM mappings. So now I'll pass it to Thomas.
Yes, thank you. It's working. Okay, I will take over by displaying the highly detailed data flow in the tool. As Manasi said, we have the entry file that is read by the P21 Spec Creator, that is then giving us the upload file. And the P21 Spec Creator is, from the user's point of view, just a SAS program that calls a number of macros, modules as we call them. And they are essentially all equal, as Manasi also hinted to. But some of the modules are more part of the driver program than others. That goes for the Excel import module that reads the entry file and stores each data set or each sheet as a oops, that was actually the wrong one. There we are. Was in a number of data that's called entry underscore sheet name. And then on the other end we have another central module called write sheet that takes a similar bunch of data sets, just called P21 spec underscore sheet name, and write them to the upload file. So at this stage, we are not looking back towards the entry file because it's all in data sets, and we're not really thinking about the upload file because we're just producing data sets. But going from this block up here to this block is where our actual working module comes into place. And we will go into the details later with all the modules, but as Manasi said, they are just small building blocks that are designed to be executed one after another. And to help this and prevent modules from interfering with each other and do cross-contamination, we have some concepts or standards in place. We have a macro that helps the modules clean up work. So they're only leaving what was already there when the module was executed. And of course also the intended output of the module is kept. And that intended output can be one or more of the sheets, but they should follow the name, like indicating what the sheet name is and what was the name of the module last working on the dataset. And that name of that dataset will also be stored, or must be stored, in a macro variable. So the next module that wants a certain sheet can just resolve that variable and go on from there. When all the modules here have done their jobs, we have another of these central modules that finalizes the datasets, basically reordering variables, dropping a few temporary variables, and sorting the data so they look exactly as we want them to look in the output file, or the upload file. So onto the modules. One of them is what we call the core module, or the add core. That is a kind of a copy-paste of variables already defined in one dataset into another. And we do this by one of these additional columns Natalie mentioned. We have the core variable column where we can fill in an integer, and thereby defining this as a part of a core group. So in this example, we have the core group 1 in ADSL, that is study ID and user ID. And we have the core group 2 in ADSL, that is ARM and ADaM. So if we have this in our entry file, our upload file will look like this, where we have, as you can see, all 4 of these core variables added to ADAE, and only the 2 in ADMK. And we also not only fill in the variables, we also fill in the labels and other variable attributes as well, and we also set the comment flag. So a lot of manual work saved there. Oops, and I forgot to mention that this is not exclusively for ADSL, it also works on other datasets, it works on SDTM, and even on, in theory, we could create dummy dataset with selections of timing and treatment variables that we also want consistency between. And other module is the author method. That is a way of specifying, or allows us to specify methods in 2 different ways. The first one, and the most interesting, is inline. As you can see here, we have basically removed the columns that are normally found in the method sheet, the expression context, the expression code document. We also have the page column, but we ran out of space. They moved from the method sheet to the variable and value level sheet, where we can just put all information related to that method in line with the variable, as shown here for the first line. And as shown in the other line, the green one, we can still produce or insert normal references to a method. The more generic method we usually just ADY, everybody knows that more or less. So in the upload file method sheet, we will basically just carry over the information we put in the entry file and create a new row with that method information. And we will derive a name and an ID. And that ID will then just be inserted as method in the upload files, variables, or value level sheet. And the standard method is just left as is all the way through. And this same concept also applies to the comments sheet. That is essentially the same thing. There's only document and paste as far as I recall, but now we had the concept, so we could just use it for comments as well. Code lists, another fun thing. So of course we have a module for that, and we don't want to edit all the code lists and maintain them in the entry file. That's just no. So we rely on a central trial level metadata set with all the code list and code list-like information being available. So we can just select what's in that data set that we actually refer to from the variable or the value level sheet, and that gives us that sheet data set for the code list sheet in the upload file. So that's a pretty simple module, but of course the challenging part is to create this trial level metadata sheet containing everything. I think we had a little ending of it in the previous presentation. And I will not go into details how we do it here, because it's just a topic for another presentation and another year, and actually I guess it's still a bit of work in progress, but essentially it's a collection of all available sources with some slight modifications, because data management might use some different terminology than we want. We have external vendors that are maybe not up to speed with C-disk standards, and we have medical writers who want to show something else because that's what they are used to in their world. So yeah, I guess that's enough rambling for me, and I'll better pass it on to Malte again. Oh, no, it wasn't absolutely not enough. The benefit of going through all this work with these data is of course that we have the same data available for programming as well as Define, and thereby we also keep both the data sets and Define in sync. And now I guess I'll think one more. If all this fails, all this fancy automation, we can still put in values in the entry file's code list sheet, and they will be included in the upload file exactly as we enter them. And in case of conflicts, the manual enter thing will win. So the user or the programmer is still in control of everything and can kind of reject the automatic generated things. And now let's back to Martin.
So one of the key enhancement of our framework is the VLM generation using the get VLM module. So as name indicates, it automates the VLM generation, yet allowing the programmers to manually enter the VLMs in the entry specs. So it reads the VLM target variables, uses the selection criteria to build the where clauses, and then also fetches the data type, length, significant digits, and formats from the real data sets. In case of conflicts between the automated entries and then the manual VLM entries, we let the human win, of course, until the AI take over. So, and all these conflicts are flagged clearly with the VLM source flag. So it's for the programmer's discretion and curation. So in the end, all the manual VLM and the auto-generated VLM will be saved into one write protected Excel sheet and clearly marked with the VLM source. Yes, we haven't stopped there with the Define-XML creation and dataset creation, but we went beyond that. So the first plugin is the ACRF generator. So get page numbers module extract the CRF pages based on the information in the entry specs and also the EDC raw data specs. So it reads the page numbers of each form and variables present in each CRF form and add the annotations automatically onto the ACRF PDF document. So it of course saves all the tedious manual work, but it also helps us to constantly update the annotations on the ACRF. And the next one is the raw data to SDTM mapping checker. So it compares the EDC raw data specs with the information in the entry specs, and it will flag in case of any discrepancies or in case of missing mappings or typos and inconsistencies, and it helps the programmers. But of course it doesn't check for the correctness or the mapping logic, but it will only check for the completeness. So it is a helping tool for the programmer to review the raw data to SDTM mappings. So in short, we automated the boring parts, reduced the risky bits, and we kept the fun part. So our framework is robust, reliable, and user-friendly interface, and of course it's a modular design, and it's a smarter tool, so it reduces the manual work, and of course enhances the quality. So it saves the manual work, and it reduces the errors, and increase the efficiency. That makes programmers happy, and you know, happy programmers means better submissions, and unhappy programmers means a long issue logs. So thank you for listening. Thank you very much. Time for questions, but compliments are also